Hello everyone, welcome to this J4K 2020 hands-on lab called Hands-on with Quarkus, Building Generation Kubernetes Native Java Apps. My name is James Falkner, Product Marketing Director for Red Hat Runtimes and Quarkus at Red Hat, and I'm going to walk you through the lab today. You've probably seen a bunch about Quarkus already at this event, so I'm not going to spend too much time introducing Quarkus, only to say that it's a next-generation Java framework built for speed and small constrained environments like Kubernetes. Very fast startup times, very low memory usage by moving everything from traditional runtime all the way back to build time, along with some great developer product features that you'll learn about in this lab. Quarkus really targets new cloud-native apps, microservices, serverless, really targeting the traditional monoliths, if you will. We do have a number of folks who are looking to transition away from traditional n-tier monolithic applications to microservices and or serverless, and Quarkus makes a great target for that. So if you want to learn more about Quarkus, you can read about it. We have a Quarkus study that we did along with IDC. If you want to try some exercises yourself in your browser, much like today, but in a smaller, faster environment, you can head over to bit.ly/try-quarkus. And if you want to get started and bring your own application, build your own applications in your own preferred IDE, you can head over to code.quarkus.io and generate new projects. Select your dependent, off you go. So that's all I'll say about Quarkus. So for the lab itself today, you've got about 2 hours. What you're going to learn, first we'll do a basic hello world introduction. Like every new technology, you got to have a hello world. Then we'll talk about basic dependency injection, a mechanism within Quarkus apps, and indeed found throughout the Java universe on injecting dependencies with type safety. Then we'll talk about how you test and debug Quarkus applications in your IDE. We'll then move to talk about native compilation. One of the big features of Quarkus is the ability to build native applications, which start up very fast and consume very little memory. Still Java, so it's a great target for migrating. We'll shift over to Kubernetes and talk about how Quarkus apps get deployed to Kubernetes and how you can add some cloud-native aspects to your applications like health checks and other aspects using some APIs like Microprofile and others. If you have additional time and you want to continue your journey, we do have optional exercises you can complete. I'm not going to go through them in this video here, but you can continue your journey for the remaining time that you may have to do additional more advanced things like doing database access, event-driven reactive messaging. We've got some exercises using Kafka, monitoring with Prometheus and Grafana, how you can do tracing with Microprofile, and how you can secure your applications again with Microprofile and a OpenID Connect backend. In this case, we'll be using Keycloak. So again, options, you don't have to finish them today. If you have extra time, you are more than welcome to continue your journey. So to access the lab, you're going to head over to bit.ly or bit.ly/Quarkus-J4K-2020. And then from there, you'll be given links specific for you for this particular lab that you're doing today. The password for all of the services that you'll be using today is Openshift, pretty easy to remember. Openshift is Red Hat's Kubernetes distribution, and we'll get in the lab today as well. So very easy to get access to your lab. You'll just click that link in the previous URL. Again, just as a reminder, it's bit.ly/Quarkus-J4K-2020, and I'll put this in the chat as well. So you can easily click on it, or you can just type it in directly. When you go there, you'll get a sign-up page where you'll enter your email address that you signed up for J4K, and the password again is Openshift. And then once you register, you'll then be given a link to the basic Quarkus development module, which are those first 7 things that I talked about earlier, the Hello World and some introduction to Quarkus. And then you'll also be given a link to the advanced Quarkus development if you have additional time to complete those. By the time you get there, you'll be very familiar with this interface, so you won't need me to walk these. But I walk through the lab today, the first, the basic Quarkus development to get you started. So again, as I mentioned, you'll be using OpenShift. You will also be providing IDE, or an integrated development environment, based on Eclipse Che, which is an in-browser IDE, so you don't have to download anything or install anything on your laptop. It's for you directly in your browser. Okay, so let's go ahead and get started. So let me break out of here, and I'm going to head over to that link that I sent to you, and you'll be landed on this page here. Let me make it a bit bigger. So let's enter my email address, and then password is Openshift, and I'll save that just for fun. And now I have this page here, linked to the basic and advanced Quarkus development. You can tabs open, and if you come back to this page, if you accidentally close the tab and come back, it'll still remember you via a browser cookie, so no worries there. So I'm going to go ahead and get started. These other links down at the bottom are just handy links in case you need them. A link to the Openshift console and a link to the Code Ready Workspaces console, which is J IDE. But again, the links that you'll need to follow are the instructions that I'm about to walk through. So I'll click on Basic Quarkus Development. It'll open up in a new tab, and you can see a list of the exercises that we're going to do today. The first step is to set your username, which it should already be set for you. Since I am the first user on this, I've gotten user ID of user1, which I can see up here in my browser. Make this a bit bigger as well. If it's wrong or you need to enter something different, you can just click the little green icon and enter something different. But make sure you use the one that was assigned to you, because other users will be using different user IDs. So you can a little bit more about Quarkus. There's a couple of links, handy links if you want to read more, but we'll just scroll down here. These instructions, when you click on a block of code or a block of text or a block of Linux commands, it automatically copies it into your clipboard. So if I just click here once, that automatically copied, and I'll be able to paste it wherever I need to paste it using Control V or Command V or even the menus Shift Command V or Shift Control V if you're in a terminal. So that's good for code as well as Linux commands down here. If I click here, it copies it into my clipboard. I could actually come up here and paste it if I wanted to, but that's not a valid URL, so I won't do that. But later on you'll see how this works, and you'll just easily be able to paste it directly into your IDE. Okay, so to access the IDE, the Eclipse J workspace or Code Ready Workspaces, again based on Eclipse J, we have a link here. Started, access the Code Ready Workspaces instance and log in using the user ID I was given and the password. So I'll go ahead and click that, and I'm going to leave the instructions in this other tab open while I work through this. But I'm going to log in here, user1, and password is Openshift. And this will take me to the console. And in this console, I can see my one workspace has already been provisioned for you. You can just simply click on it over here on the left, and it should open up my IDE. And while I'm doing that, I'll just shift back over to the instructions and scroll down. Yep, I click that, and then I'll be placed in my workspaces. So I should end up on this screen here momentarily, and indeed I do. And it's going to give me my little welcome page. So if I then scroll down, okay, that's it. So if it gets weird, if something seems odd in your browser, you can simply reload. So anytime you're in this screen, I can just reload the entire and it'll kind of reset, and you won't lose any data or anything you've typed in. Everything's automatically saved. But if something gets weird or a menu option doesn't work that seems like it should work, you can just reload the page at will, and you won't have any issues. So I'm done with this page. Click the Getting Started with Quarkus to take me to the next section or next exercise. So now I'm on exercise number 2, and this is the Hello World. So we're going to create a basic application that is a RESTful URL backed by a hard-coded greeting service, and then output something if I access the URL. So the Code Ready Workspaces, there's a number of different icons on the left here that you can click through. There's a file explorer, there's a search, there's a source control, and then also debugger. These should look familiar if you've used Microsoft Visual Studio Code or VS Code, because they're based on the same upstream source. So it's a very similar environment to VS Code, but it's directly in your browser. So you can click those at will, and you will be using those later on. If you need to run a command that doesn't appear in a menu or something, you can hit F1. So if I'm over here and I hit F1, it opens up this, and I can start doing automatic code or completion of commands or what have you. You can do Git commands, you can do debuggers, you can do Java management, all kinds of stuff. But that's kind of a quick access if you don't see something obvious in a menu. So I'll go back to my instructions here, and the first thing we're going to do is import our sample project that we're going to be using throughout the lab. So we'll click on Git clone, and I'm going to copy this by clicking on it so I can paste it later on. So I'm going to click Git clone and then import this. So I'll go back over here, click on Git clone, and I'll paste the URL. If you're using Firefox, it might put spaces at the beginning of this URL or at the end, so you got to be careful with that if you're on Firefox. You'll get a weird SSL error if you try and import it with a space in it. Just make sure those the URL here doesn't have any space at the beginning or the end. Click return, and now it imports that from Git, and now I have my project here imported into my workspace. So the next thing is, and we can see that in the screenshots. So the next thing is to check out a special branch. So we base the source code on versions of Openshift, as there's different features in different versions, and so we want to make sure and check out the latest revision that corresponds to the Openshift we're using. So we'll go ahead and click here, come over here and run this in a terminal. So the way you open up new terminals here is this little box on the left. You have a number of different commands that we'll be using throughout the day, but the first one we'll be using is terminal. So open up a new terminal and then simply hit Command V on my Mac to paste that command, press return, and now it's checked out the proper branch for the source code that we'll be using. And it's, the application is a basic Hello World application. There's a couple of other directories in here that we'll be using later, but the basic application is, as you can see here, very simple. Hello. You can exclude globally if you get this pop-up here. That'll only show up one. So this is the basic Hello World application with a basic resource, Java resource, RESTful endpoint on /hello. So if I go back to the instructions, it tells me, and I'm going to start up Quarkus in what's called live coding mode. So there's a menu option to do that. So I'm going to click start live coding over here, and it's going to run in a terminal. It's going to run Maven Quarkus dev to put Quarkus in dev mode. And you can see Quarkus opens up. It opens up a port on 8080 because that is the default, and I'll hit open link, and it's going to open a little mini browser directly in my IDE, and you see application not available. It takes a few moments to set up that underlying infrastructure because it creates a Kubernetes service, and then it creates an ingress or OpenShift route so that you can get to it from outside. It also opens up 1005 for debugging, but we don't want to open that in a browser because it's not HTTP protocol. Here I'll just click reload and it should be ready now. So my application is up and running. This is the basic Hello World web page or index.html included in all default Quarkus projects that we'll be replacing soon. But that just lets you know that the app is running, and Quarkus is running in dev mode. And we're going to leave it running in dev mode for the entire lab, and we'll be making code edits as we go along, and you'll be able to immediately see changes. So let's go back over to our instructions. We've done this part. We have our application running, and we're also going to run this curl command just to test out the API endpoint. And if I go back to my workspace here, I'll go back to my other terminal that I already had opened and just run this curl command, and I indeed get hello, as you can see, which is what was expected. So the next thing we're going to do is exercise the reload capabilities. We're going to change return hello to return hola in the editor, and then run the curl command or reload the browser again. So if I go back to my my greeting resource here and change hello to hola, and then run this curl command again, we should get hola, which in fact we do. So that's sort of the live reload capabilities of Quarkus. It works for both code changes as well as like pom.xml changes if you're using Maven to bring in new dependencies and automatically reload the application very quickly. In fact, if I head back over here, you can see the reload occurred here in about half a second. So it's pretty fast edit, save, refresh cycle, which is an important aspect of Quarkus. Okay, so that's cool. You can read some more about what Quarkus dev means and what development mode means. We will explore this later on. So the next thing we're going to do now that we have our app running is we're going to package it into an executable or Uber jar, making this package app for Openshift. So if I go back to my browser or my IDE and click the little box here, I can click package app for Openshift. This simply runs Maven package, right? It's not a lot of rocket science going on here, and it's going to generate a jar file in the target directory, like every other Maven project. And you can see the jar file has been created here. So if I continue down, I can see my jar file, and now I'm going to run it. Now remember, we have the application running already in live coding mode, so we need to change the port number so there's no port conflict. So we'll run our temporary application on 8081 just to confirm that it is indeed working. So go back here, click, paste this command, and it's in the application. Again, still running dev mode on port 8080. Now we have this temporary app running on 8081. So I will go back here, and we're going to run this curl command to confirm that our application is indeed running. I'll open up a new terminal and run this curl command. 8081 is still running, getting hola as expected in our temporary application. So we just built a Uber jar and ran it and made sure that it's working. So now we're going to stop the Uber jar while we keep the other one, the live coding one, open. So Control C this guy. You can close these terminal windows if you get too many open and you don't want to have the mess on the list of things here. You can close these too when they're done. So you can kind of leave, you can even close the problems one. So you can just leave the terminal commands running that you're actually using. So we'll leave start live coding. You can see I have this yellow bar at the bottom that says offline. It somehow got disconnected, so I can simply reload the page, and I should come back to the IDE just as it was in the before I reloaded without losing anything. I think I actually opened the jar file in the text editor, which I think might have caused some issues in Che dealing with all that binary data. So in any case, it is open. I will go back to my, the test is now broken, which will minute because I changed some code without updating the test, which is a bad idea. That's part of the lab, and we're going to do that. We're going to fix that up in a minute. Okay, so we have our live coding still open, hopefully. Let's see, I've already started. I just started another one. It's probably going to fail. Yeah, it's probably going to fail because I already have it running. So we will close that, and we are going to open a new terminal and just kill the live coding because I think I lost my live coding window, even though it's still running. So I'm just going to pkill -9 Java, or no, runner, pgrep-f runner, not runner, Java. So I have a couple of Java commands running. I'm just going to figure out which one I need to kill and kill it. So it looks like it's number 81 here. So I think I can just do pkill-f Java. That should eventually kill it. We'll just kill everything. Okay, it looks like they're shutting down. So let me just start up live coding again. Okay, so I've got my my application still on 8080. I do not want to open port 5005, and I've got my test application running in live coding mode. So we'll go back to the instructions. Looks like that was the last step in this part. So we'll move on to the next one around dependency injection. So the next part is around dependency injection using CDI APIs in Quarkus. So the first thing we're going to do is add a custom bean. So we're going to create a new file in the service folder, and we're going to call it greetingservice.java. So I will go to the service, right click, new file, greetingservice.java, and then I'm going to take the code from the instructions. That's copied, and I'm going to go over here, click Command A, and then Command V to paste this code into this new file. So I'm going to replace the contents with all of that. And then I'm going to open up the existing greeting resource and add a new field and method. So I'm going to add this field called service, and I'm going to add a new method called greeting. So let's go back to greeting service, or greeting resource, and I'll put my cursor here, and then just paste. So now I have a couple new fields, one new field, one new method. You can see they're also showing red, which is the next section here. So we're going to clean those up. We can either paste the imports directly. I'll just do that for now. There's also a way to do it one at a time by right-clicking and saying import, but we'll just make it easy and just copy and paste this into our project here. So that should get rid of those squigglies. And now I'm going to, now that, again, remember everything's still running as live coding. So with those changes, I should be able to immediately access the new endpoint that I've added. So I'll add that. I'll open a new terminal and paste, and I should get hello Quarkus from something, which I did. the name of that endpoint will be different. That's the name of the service that's automatically generated in Kubernetes for my running application. That would be different in production, obviously, but that's the one we get for now. Okay, so that works. So that's basic CDI injection. You use inject greeting resource in this, or greeting service in this case, and then the bean gets automatically resolved and injected there as well. And there's some additional options you can use to control the life cycle of these beans that you can read about on quarkus.io. Okay, so the next one is around testing. So we're going to be using JUnit. Quarkus has an extension in it. It also makes the Quarkus test annotation available, control the testing framework. So we're going to create a basic test in, not this one. This is, notice when I click on this, it doesn't like select it all and paste it into my clipboard. That's because we're not asking you to paste this code. We're asking you to paste code later on. This is just an example, but that's the way. And you'll find these dependencies in your pom.xml that automatically add testing support for any Quarkus app. So if I head over here and look at the pom.xml, which was given to me, you can be JUnit and rest assured here, which allow me to do automatic testing of my Quarkus apps. Okay, so that's the basic endpoint, which is already there in greeting resource test. And if we click on it, you'll be able to see that here. And if we then note that whenever you're creating new tests, make sure they go into the test directory, not the main directory. In Maven, the typical Maven, an expected Maven structure is a source main and a source test for holding your test classes. So we're going to create a new test in the existing greeting resource test. There's a marker in the code that you'll find, which is add more tests, and we'll just take this by clicking on it. It's copied, head back over to greeting resource test and paste it into that spot that's been made for me right here. So I'll just paste it and head back to the instructions, and I'm going to test it. There's a run tests command that you can run, so I'll do that, and what's going to happen is it's going to run the tests, the unit tests that I've created, and it's going to fail because the changes I made earlier from hello to hola, I didn't update the test, as I mentioned earlier. So you can see the expected was hello, she got hola. So let's head back to the code and fix that real quick. And we'll change this back to hello, run the test again. Notice when I click run test, it'll start up another window here, so I can close this other one and keep it tidy here. So build success, my test passed, and I'm all good. So I'll scroll down. The next section is controlling the test port, so you can change the test port depending on if you want to run an application on one port and run your tests on a separate. You'll basically take this and stick it into a new file that you haven't seen yet, but it's in source main resources application.properties. And I'm just going to paste this Quarkus HTTP test port, run tests again. Now when I run these tests, it should run on port 8083. Which you can see here if I get rid of these guys. These automatically go away on their own, but there's the 8083, so it ran the test successfully again on a different port. So that's how you control the test port within Quarkus. Next is injecting Uri. So this allows you to create test harness code and then refer to it by injection. So we'll do that. So the first thing we're going to do is create a test.html in our project, and it's going to have this content here, so I'll just copy it to my clipboard, and I'm going to put it under, if I go back here, source main resources meta-inf resources. That's where it's expecting. That's where resources get copied. They get copied into their final resting place in the class path later on. So source main resources meta-inf resources, and we'll create a new file called test.html. Paste the content, go back to our instructions. We did this, did that, did that. Now we're going to create a new test class called static content test alongside our existing test. So I'll click that to copy it, and then head over here and do static content test under this directory here, static content test.java, and then we'll paste our static content test in, and then we were going to run the tests again to make sure they pass. And then if you read the instructions, it kind of explains how you're doing this injection, but you can see it right here. It's a test HTTP resource injection of test.html, and you can inject other resources as well as necessary for building and running your Quarkus tests. So it looks like it was able to access the HTML file. The test itself basically just looks for a title with a hard-coded value here, just to show you how you inject test resources into your test classes. Okay, let's see. So the next thing is injecting regular CDI beans into your tests. Again, using the same kind of mechanism we used earlier. So we're going to create a new test called greeting service test, or sorry, new test called greeting service test, and we'll use this for the content. So I'll head back over here because we're going to test our services directly, our services in our application directly using a test. Because we have a resource test, we don't have a direct service test. So I'll create a new file, greeting service test, test.java, and I will paste this content in, head back to our instructions, and then we're going to run the tests again, run tests, and while that's, head back to the instructions and kind of read about what a CDI bean is in Quarkus and some of the different lifecycle options you have around transactions and data retention policies, and being able to put multiple annotations together in a stereotype, all the same kinds of things that you find in traditional Java CDI. So that looks like that passed. With our new test injection, we basically injected the service directly and then called its API and then confirmed that it returned what we needed, as opposed to testing the HTTP resource endpoints or injecting test resources. We can just test the service directly. The next one is mock service or mock support. So in this case, we want to provide a test version of our service without having to edit the code, the code of the application itself. So we mock our greeting service by creating a mock greeting service annotated with mock, which will tell the Quarkus testing framework that we're going to use this service in place of the greeting service whenever it's needed. And then we should, when we run the test, we should see this test message here. So we are going to create a new file called mock greeting service in the same directory, mock greeting service.java, and paste the same code in from the instructions. So this is our mock greeting service. It exposes the same API or interface as it extends from greeting service, and then we're overriding the greeting method. You can override other methods as necessary. For example, instead of connecting to a very expensive database, you could have like a local database or something like that for testing purposes. But with this mock in place, we should we're going to add another test, or we're going to add a log statement to the existing test by replacing this test greeting service method with the same method but with an additional logger line. So we'll go back to our greeting service test and find our method here and replace this method, which is in effect we're just adding a one line to show the value on the console. So now we're going to run our tests. So I'll go back here and click Run Tests again. And now, as part of this output, we should see that that test message from our mock greeting service. We should see something like this, which should be easy to find with these arrows. So if we scroll up in the output, we should see the test value here somewhere. If I can find it, it's right here. Let me get rid of this extra junk on the screen. But there's our mock greeting being used when we run our normal test. So it's effectively replacing the service in the application with our test mocked greeting service. So that's it for testing. So there's a lot of other things. There's actually a full testing guide, a Quarkus testing guide, if you want to read about some more examples and some more concepts that you can use in Quarkus for doing testing. So let's head over back to our instructions. So we're done with this. So we're going to go on to the next section, which is debugging. So this one should be familiar to any Java developer. We're going to use the debug framework inside of our IDE. We're going to add a method that has a bug. So we're going to open up our existing greeting resource and add a new endpoint called last letter, which gives you the last letter of whatever name you pass in. So if I pass in the name of James, I would get back an S. So I'm going to paste this into our greeting resource, class. I'll just put it at the end. And there it is. You can clean this up if you like. And now, with that code in place, I should be able to access this endpoint, which is our new endpoint called last letter. I'll pass a foo, and I should get back an O, but I'm not because there's a bug, and we're going to fix it. So let me go over to let me close some of this stuff here. You can close these that are done with a check mark next to them. Here's an open terminal. I'll just run our test here, and I get back nothing. I get it back blank, which is a bug, but that's expected. So if you read on in the instructions, you'll see where the bug is. So we're basically taking the length of whatever the name was passed in. So if you pass in foo, the length would be 3. We're looking for the index of the last letter, which would be at the length of the string, and then we'd output the last letter in the Quarkus log. And if I look at the Quarkus log, I should see got last letter and then nothing. So if I go over here and go to my live coding menu, I indeed see got last letter and nothing, and that's because this bug here, the length is wrong. It should be length -1 since it's a zero-based index. But we're able to reproduce the bug, so we're going to attach the debugger now. So to attach the debugger, to discover this, we're going to head over to the debug menu here, or debug pane, and it's already been configured for you, so you're simply going to click the little green arrow to attach the debugger to the app. You can ignore this difference in JVM versions. It's not big enough to warrant a concern. If you're in production, you'd probably want to make sure you're matching exactly the JVM versions, but we're version 11.07 in our container image, which we haven't updated yet, and we're using 11.08 in the IDE, but no big deal. For the purposes of this part, it doesn't matter. So we've attached our debugger, and we're also going to create an endpoint, or create a breakpoint. We're going to create a breakpoint right here, line 40. And to create a breakpoint, you move the mouse over to the gutter over here, and you see these little red bubbles start showing up. If you click on one of them on the line you want, it creates a breakpoint. You can see the breakpoint was listed here. So now I have a breakpoint. So if I run my test again, I should get a breakpoint, and it will stop at that breakpoint. And I can see local variables here created. The name, which was passed in as part of my URL, is here in our local variable name. And then if I can click these little buttons over here to advance, to step over. So I'll step over that value. So now I have len, len is 3, that's expected, the length of foo. And then the next one is where the bug is. So if I click step over, last letter is now blank because of that length is wrong. And then if I step over that, and I'll just continue, I'll press the little blue play button to continue, and I get, it finishes, and then I get nothing. So that's the bug. So I'm going to fix the bug. The super easy fix here, length -1. That's the fix. So I'm going to run my code again after I fix the bug. Notice I didn't start or restart anything. It's just automatically done in Quarkus. So now if I skip over this line, I should get a last letter of O, which is what I would expect. And so if I'll just continue it, and now my curl command finally finishes, and I get back O as expected. That's it for the debugger. So I'm gonna stop the debugging session. Disconnects from the app. The app, of course, is still running, so I can sit here and do other things, like I can run that, I can do that, and I'll put a 4 at the end, and I get a 4. So now my code is working as expected, and I was able to use the debugger to figure that out. So that's what all this content is over here watching this. So feel free to step through that. But I just did everything these instructions say, so congratulations to me for figuring out the bug and using the debugger to step through and fix the bug in real time. So the next topic is building native Quarkus apps. So this is a new feature for a lot of Java frameworks, the ability to build a native app. And we use a technology called GraalVM, which is a polyglot compiler and executor of Java code and other languages. We're using the Java compiler from GraalVM, as well as the substrate VM, which is the actual VM that runs in the native image. We're basically going to take our application, this greeting service and greeting resource, produce a binary executable, and then just simply run it. And it's pretty easy to do. We've already installed GraalVM for you. You can see if I paste command line, it gets listed there. And then we also have a Maven profile called native, which controls that native compilation. So if I head back over, click on my little file explorer, and then look at pom.xml again that we looked at earlier, scroll down, you'll see there's a native profile here, which controls how the native profile is built, what the name is, and then some additional properties that we use in Quarkus. Pretty simple, but what this really means is it's a simple one line to build a native application. So I have a menu item that we've created so that you can build this native app very easily. I'll click on it and then kind of describe what's happening here. But it's basically running a Maven command which invokes GraalVM to compile the application down to native. Usually takes about 2 minutes to complete on this system. Depending on how complex your app is and how powerful the machine is that's compiling, it will take longer or possibly even shorter. If you're running on, say, Mac or Windows, and you intend to run your native Quarkus app on Linux, say in a container image on Kubernetes, you can build a native image using Docker or Podman or other container build techniques. Even if you're on a Mac, you can build Linux binaries, or if you're on Windows, you can also build Linux binaries. And there's a link in here that talks about how you would do that. But the end result is basically it takes the Quarkus. The way the build works is it takes the Quarkus app. It builds. It does a lot of framework initialization to let frameworks initialize themselves, and then kind of essentially, for lack of a better term, it records what happens at build time so that at runtime it can play that back and be very fast when it starts up. It's not exactly like capturing a snapshot of memory, but it's doing a lot of pre-work on frameworks like building meta models, annotation scanning and processing, class path scanning and processing, config file, all kinds of stuff, because we're kind of assuming, and this is how Java fits in this new world of containers and Kubernetes, is that it's an immutable architecture, and if you're going to change the app, you're going to go back and build it again. You're not going to SSH into a running machine and make a production level configuration change. So immutable architectures means that we can build everything at build time and know exactly what's going to happen at runtime. This is also known as a closed world assumption. So that's what's happening in the build here. That should be done in a few more seconds. It's doing all the framework initialization in Quarkus, and then it's passing that to GraalVM to compile it down to native, to produce that native executable, which should be done here in a few moments. And that's what we're doing here. And once it's finished, we'll just have a look at its ELF headers. ELF is a file format, stands for, I think, executable linking format or something like that. It's a way that that Linux binaries get linked together and executed at runtime. So, and it's got some header stuff in there that kind of describe what the content of the native executable is. So it looks like it finished now, so we can open up our command line terminal, and we'll just paste this command in. And we can see that indeed it is an ELF64 binary with 2's complement little endian formatted data. And these numbers may mean something to you. Some of them mean something to me, but most of them I would not know what to do with. So that is our native binary. If we look at it, if I go to the target directory, actually, where's my target directory? cd $che projects root / Quarkus labs workshop labs, and then I go into the target directory. You can see our native binary right here, 27 megabytes or so. I think that's it. Yeah. And so I'll head it back over here. So now we can just run it, right? We don't have to do java-jar run it directly. Now remember, we have our live coding app still running, so we want to make sure and alter the port that it runs on to be 8081. So we'll do that. So I'll just click here, run it, and you can see it starts up pretty fast. This one's 18 milliseconds, running on port 8081. It's the same application running. If we look at the memory usage by opening up another terminal, we can run ps and get that it's about 73 or 70 megabytes of resident set size memory, which is pretty compact for compared to a traditional Java application. It gets bigger or smaller depending on how complex your application is. This one's not completely hello world, but it's close. And so let's just test it out, and we'll run this curl command to see that indeed it is running. Our memory is running. And I saw that. Okay, so I'm all good. So that's a basic introduction to building Quarkus native applications, there's a lot more complexity if you need to do things like reflection, where you need to provide hints to the compiler that you will be doing reflection and take that into account, because by default everything needs to happen at build time. So if you're doing reflection at runtime, then that's not going to work without declaring that. So you can do it, but you just need to declare that kind of stuff up front. And that's all listed in the Quarkus native guide on Quarkus.io, which I believe is a link somewhere in here. If not, you'll be able to find it on Quarkus.io pretty quickly. Okay, so that's it. So we need to Control-C our native application, because we're going to build it again later and deploy it to Kubernetes. So I'll go back to my native application running here, and I'll hit Control-C. Again, I'm going to clean up my things that don't need to be opened here. We're done with the debugger, so I'll just leave the live coding window open for now. Okay, next is developing cloud native. So this is where we're going to add things like health probes, other stuff, and that requires in many cases an extension to be created or to be added to our project. Quarkus has a Maven Gradle plugin that can do this, so we'll use this command here to add an extension called health, which will then add the Microprofile health extension based on this project. So if I head back over to my terminal and run that command, open up a new terminal, and this simply is a handy way to add something to your pom.xml. I could have done it myself, but the plugin will do it for me. I'll ignore that for now. I'll synchronize my Java class path always. The first time you add a new extension, obviously it changes the build path in the IDE, so it recognizes that and asks you if you want to do it. If you want to update it always, then I do. So it just added this line here. You can even see the green bar here showing that I've changed something in the source through source code, which we'll take a look at later. But it added this extension here. So back to the guides here. I added the extension, and now simply by adding that extension, I can run and I can access the health endpoint. If I click on curl command, I will get my health endpoint, my default health endpoint, which is everything's up and running. If I add curl-I, you can even see the HTTP return headers that are returned, and I get a 200 OK. So that's all good. So we're going to add a health probe, a simple health check called, in fact, simplehealthcheck.java, which will simply return up, but it will do so in code, so that and then we'll go off and edit that later. So we'll create a new file under the health package called simple health check. So here's my health package, new file, simple check.java, and then replace this code with this code, and now I have my simple health check up, and now it kind of describes the difference between the instructions describe the difference between liveness and readiness probes. We have simply added a readiness probe that tells Kubernetes when the application is ready to receive traffic. If that ever becomes false, then Kubernetes stops sending traffic to it until it recovers. So it's kind of a good way to keep a pod healthy or kill it and replace it with a different pod. But now that we have our health check in place, I can run this command again, same command, and I should get my two checks. I have the simple health check up that I've created here. We have one health check here instead of the default one. So this is the one that gets returned as simple health check, and everything's up and running. So that's our simple health check. Now we're going to add a new health check that also returns data. So in this case, you can return some data showing why something might be dead or not for diagnosability later on. So we're going to create another one called data health check. This one is going to be just adding some data into the response. So right click in here again, new file, data health check.java, and then we'll replace this code with this code. And now if we run, this is a liveness probe, not a readiness probe. So if we just ready, we're not going to see our newly added thing. So we'll do health live. So now we can see this health check returned the health check with data. It could be data that you get from a database or some other runtime value that you want to show in the health check output for monitoring and diagnosing of issues later on. So that's our simple liveness probe. By the way, you can access both of them, both health checks. If you just use /health on its own, it will show you both. It will show you both the liveness and readiness probes that you may have set up. But generally, you want to separate those in Kubernetes, because Kubernetes treats liveness and readiness differently and reacts to the failures of liveness and readiness differently. And you can read more about that in the instructions. So we see our data value here. Now let's test the negative case where something is not up. So we're going to create a database connection health check, which will let us know if the database connection is valid and up and running. So this is another file. We'll just create a new file, database connection health check.java, and more the code. And this one runs a simulated database connection verification. So normally you would actually try and access the database, but we don't have a database yet. That's coming later. But for now, we're going to simply return the value of this config variable, which we'll be able to control in our application.properties file. So if the config variable called database.up is false, then our database will not be up and will fail. And the default value is fail, so that's good because we're going to test it right now. So we should get this default value. So if I run, if I access this health endpoint, the other ones are up. This one is up, this one is up, but the database is down. So it returned down, and if I run it again with -I, you can see that I got a 503 service unavailable, which would be an indication to Kubernetes that this application is not ready to receive traffic, and it would take it out of a load balancing pool or stop sending traffic to it. So if we go back to our instructions, this is what we just did. We got a 503 service unavailable, and we saw could not contact database. So normally that would be a real failure, but in this case we're faking it. So we're going to just set this value of database.up to be true in our application.properties file to quote-unquote fix our problem. And now if I run this again, I should get, clear it, I should get success. So everything looks to be up now, and I have HTTP OK. So that's all good. Let's turn my notifications off so you guys don't get annoyed by that. Okay, so back to our instructions. So that's the, and we already talked about this, where you can access health checks separately between liveness and readiness if you want to test different things. The last section here we're going to talk about, and we started to use this in the lab just now, is externalized configuration. So this is a way to access configuration values from our properties files, or from environment variables, or from any other source really. Kubernetes config maps, or config servers that you may have. And then you can declare those and inject them into your applications using this config property, which is part of Microprofile config. So we're going to inject some config properties here in our greeting resource that we're going to use later on, just below the inject greeting service. So if we head back to greeting resource, and we have up at the top we have our greeting service injected. Now we're going to inject these three config properties. You get the little squiggly, which you can find the import, or you can just click on the little light. Actually, you can click on it and then import config property from Microprofile. So I'll automatically import those, and then we also have to import Java's optional API, which is java.util.optional, to get rid of that one. Okay, so that looks good. So now that we have these config properties injected, we'll be able to use them in the code. Again, you could have done this by just putting these imports in, or using the quick fix. I just use the quick fix just for fun. Now we're going to modify the hello method to return and use this these new config values. So I will modify the hello method to use these injected properties. So back on here, here's my hello method. I'm just going to replace it with that, and now that's going to return the value of message plus a space plus the value of name. If name is not defined, return world, and then the value of the suffix. So those three config properties that we've declared up here, it's going to use those. Let's see, back to the instructions. So we need to create these values in our code. So we're going to create greeting.message and greeting.name. So if I go back to my application properties, I'll just add these at the bottom. So now I should get, if I access the endpoint, I should get, let's see, message is hello and name is Quarkus. So I should get, where's my hello endpoint here? I should get message, well, you'll see what we'll get. Hello Quarkus, I believe. So back to the instructions. We'll access our endpoint, hello, paste that, and I get hello Quarkus, what I would expect. Let's see. So now we're going to update our test, because we'll break the test again if we don't. So I will go back to the greeting resource test and fix the test hello world, or test hello endpoint. Greeting resource test. Here, this one right here. and it modified this line to make sure it looks for hello Quarkus, which is what we now return. And so we should automatically be able to run this curl command at will to always get the right values. And if I run my tests again, I could also make sure that those tests work. Okay, next is the to add different configuration properties depending on the profile you're running. So Quarkus, when it runs by default, when you run Maven Quarkus:dev, it runs in what we call dev mode or live coding mode. You can also run it in production mode, which is the default when you're running out of a jar file. But you can have different Quarkus configuration values and prefix them with a name, which we'll get to in a minute. But that config file, that application.properties file, is kind of the centralized config place for not only Quarkus itself, but also all the extensions you're using. So if you don't know a value that is possible, you want to see a list of all possible values along with their documentation, you can run this Quarkus::generate config method or extension in Maven, and it will generate a sample file that you can use and see all the values. So if I go back to my terminal in this Maven, it's going to create this application.properties.file file, which has a list of all of the examples along with the documentation for them. So we used a couple of these, like Quarkus HTTP port earlier. We used let's see, I've used a couple of others in here. But this lists all of the possible values, including the values for the extensions that you may have installed. So you'll find like Vertex, you'll find some of the rest assured values, you'll find health check values that you can use. So depending on the extensions you've installed, you'll get additional documentation here. This file will be, we'll leave it here, and we'll just leave it here for now. But it's a good way to get documentation on all of the possible config values if you don't know what something is. Okay, I did mention you can open config values from various places, like the command, like on the command line or in environment variables, and you can refer to those in the config application.properties files. If you want to learn more, you can follow this link here about Microprofile config sources. Okay, so config profiles, this is what I was talking about, that you can run in different config files. The default one is dev when you're running in development mode, test when you're running test, and prod when neither of those two other things apply. So if you're running a jar file with java-jar, the default will be to run in prod profile. This allows you to have different configuration values depending on the environment you're in. So in this example, Quarkus HTTP port is set to 9090 unless you're running in dev mode, in which case it's set to 8181. So we are going to test this out right now, and we're going to use the greeting config values that we configured earlier, and we're going to change our application properties to have these values. You see the difference here in greeting.name. The default will be Quarkus in dev mode, and then when we're in production mode, it will be production Quarkus. So if we go back to our application.properties and wipe these out and replace them, not all of it, but just these two, and replace it with those three, and then head back to our instructions, and if we run this, since we're in live coding mode, we should get hello Quarkus dev mode, hello Quarkus in dev mode, which is what we expect. I'm going to rebuild the executable jar file with package app for Openshift. I'll click on that, which will repackage our application as a jar file, not as a native binary, but as just a traditional executable jar. And we're going to run that on port 8081 in a different terminal. And now that it's running, I'll just get rid of this stuff. We're going to open up a separate and run this curl command to make sure that it gives us a different value since it's in production mode. So if I run this curl, now I get hello production Quarkus. So simply by building a jar file and running it, it is assuming you're not in dev mode anymore, and it runs it in production mode. You can control which mode or which profile is used on the command line if you need to. Okay, so that's good. So now we're going to clean up, we're going to delete, or we're going to stop the test app that we just started. Again, we're going to leave the live coding mode open, but I'm going to close the rest of this. So here's our running app that we ran on 8081. Just Control-C that, close this. So we're good. Okay, let's see. Last one, deploying to the cloud. So this is the last step in the basic Quarkus introduction. Again, we're going to have advanced exercises if you want to go through those later on. but this is the last one I'll cover in this video today. So this is building and deploying that native image out to Openshift and Kubernetes. So the first step is we're going to rebuild our native app with all the changes. So this would normally be done in a CI pipeline, like using Jenkins or Tecton or something like that, or Travis. So ordinarily as developers, you're going to make edits in dev mode, test them out very quickly. Then when you're finally happy with the code, you submit a PR to your upstream repository. Once that gets accepted, it automatically then gets built in a pipeline and potentially sent to test or production, depending on how your pipeline is. But for today, we're just going to rebuild our native app manually with all the new stuff that we've added, our health checks, etc., and build that native app. And so while that's building, we're going to deploy this to Openshift, and we need to log into Openshift. There's two ways, or actually there's more than two, but the main two ways you access it is either via the Kubernetes API through a command line, or with a web console that Openshift has built into it. We're going to start with the command line interface. So we're going to log into Openshift via the command line by clicking log into Openshift, and we're going to enter our same credentials, which in my case is user1 and a password of Openshift. So if I click on log into Openshift while that's running my native app, I'll just type in user1, password is Openshift, and it says I've logged in successfully. I have access to one project on the system. Other students will be using different project names, so you'll only have access to the one you have. Okay, let's see. So I have my app, my native app is still executing, so it should be done here momentarily. But once it's been finished, once I'm finished, I'll to create a new application on Openshift and then deploy that out. So the first step is I'm going to create a new build of a. We're going to use Openshift and S2Y, which is a source to image technology. We've already built our native binary, so we're going to use the binary as our input, the final container image that will run on Kubernetes. So the first step to do that is to create a new build definition, which we're going to be using here. And this build definition does nothing more than take a very minimal OS image and then put the native binary in it and set that as the entry point for the application or for the container image. So we'll copy this command over here. This looks like my native app is done. So I will close both of these. I'll just and open up a new terminal to create that new build definition. And I created a couple of things in Openshift. And then I'm going to start the build, and this is the thing that combines the OS, the minimal OS image with the native binary that I just created by pointing at it with this from dash. So I will go back here and run the start build, and it's going to upload the file to Openshift and then build a final container image and then push that container image to an internal registry. So while that's going, we'll scroll back down on our instructions. So that start build should take probably about a minute to complete, and then once that's done, we'll then it'll generate the container image. Then we'll deploy that container image out to the cluster using this command here. So this should be done here momentarily. And then once we have the application deployed out to Openshift, we'll then test it using the same curl, but instead of those, we'll be using a command line to get the endpoint URL to our application that we've deployed. So looks like it's done. So now I'm going to do this new app command, which will create a new application and expose it out. And now that it's starting, we can check the status with this OC rollout command. OC is the command line interface to Openshift, which uses the Kubernetes API underneath to talk to Kubernetes and make changes to the cluster. So it looks like my my application is now rolled out, so I should be able to access it. So once that's done, I can use this curl command. If I paste it, I get hello Quarkus on Openshift. So you can see this embedded command, this OC get route command. If you just run that on its own, you'll just see that it gives you the URL to your running application on Openshift. So then if you combine that with the endpoint path here and then some Quarkus dash on Openshift, that's what you get. So it actually accesses the endpoint here. Okay, so that looks like it worked. So now it's deployed on Openshift. Let's take a look at the other way to access Openshift, which is the web console. So there's a link here. You can click on it. It'll open up in a new tab and log you in, or you need to log in. User 1, password again is Openshift, and that will take me to the Openshift console. I see I land on the projects list, which there's only one project, which is the one I just deployed. And you can kind of see some of the memory usage here, some of the statistics about the project. If I then click on the developer perspective by clicking, you'll see it over here on the left, you can get kind of a graphical representation of the thing you've just deployed. You can see it's a single pod. If you mouse over, it says one running. That's how many copies of this app are running. And you can see it's listed. If you click on it, you can get more information. You can even view the log file from the running application inside the pod, which you can see look just like the same output we got earlier. This happened to start up in 8 milliseconds, so fantastic to see such a fast startup in very low memory, which makes it really amenable to this type of an environment. Okay, let's see. We got the blue circle. Blue circles are always good in the Openshift web console. We click the view logs to look at the log file. And then we can click arrow here, which is a symlink URL to the running application itself. So if I go back here to my developer topology, I can click on this little arrow here to open the URL, and my standard output, standard default endpoint. If I add hello to it, I should also get the same output that I got earlier when I used curl. So it looks like it's all running. Now we're going to connect our health check. So when you create a new app, there's no health checks because it doesn't know how to access health on your app. So we're going to run these OC commands to use the Kubernetes API to set up readiness and liveness probes. So actually there's two commands in here, two OC set probe commands, which set the deployment to have a ready probe with initial delay seconds of 5. Every 5 seconds, if it fails 20 times, then that Kubernetes will deal with that. Then I also give it the endpoint to access, and I do the same for liveness as well, but using health ready and health live, my two different endpoints with Microprofile health. So if I run those commands, it should also automatically trigger a new deployment. Since I've altered the endpoint, so you can see a new one is spinning up, this little light blue circle in the middle. This new one's being created, and once that is created, then the old one will be killed off, and the new one will replace it. So that should be killing the old one momentarily here. This one should disappear momentarily. Once the new one is up and running and the health check is successful, then it kills the old one, and then now we're good using our new shiny microservice built on Quarkus using our health endpoints. So that's it. That's a basic introduction to Quarkus, basic CDI, basic testing, basic debugging, building native applications, and then adding cloud native capabilities to your application, and then deploying that out to Kubernetes. So that's the basic lab. If you want to then, if you have additional time and you're done and you want to continue, if you remember this page you got initially, there's a link to basic Quarkus development, and there's also a link to this advanced Quarkus development. If you click on that, then you have additional exercises here, which you can, it takes off this one left off. So you can just continue down. If you've already completed the basic Quarkus lab I just did, I can skip all this stuff and skip all the way down to the list extensions section on this page, because this is just a repeat for those who may not have executed the basic lab, or maybe they executed the basic lab a few days ago and now they're ready to do advanced. You can run through this if you want, but if you've already done it, you just scroll down to list extensions. So we'd go down here and click list or look for list extensions. I believe it's right here, and then you can start doing it. And this is a command that will list all the extensions available in Quarkus today, which there's over 200 of them. But you can run that command. You can see all the different extensions that you have for accessing things like AWS Lambda or Kafka, or doing reactive messaging, or accessing Postgres with a reactive Postgres client. There's also a reactive MongoDB client, and many other extensions that you can discover on through this or on the Quarkus.io website. So let's see, back to this lab. So that's, I believe, yeah, you just add an extension here, and then there's also some content about writing your own extension, but there's no exercises there. And then the next step is you're going to do some more advanced development with databases and a feature in Quarkus called Panache, if you want to build very powerful applications that access databases. you can use that. There's also documenting and testing of APIs using things like OpenAPI to generate documentation for your code. You can do event-driven messaging using Vertex, which is built into Quarkus. There's a Kafka section for streaming events with Kafka. There's monitoring with Prometheus and Grafana, where you set up your application to be instrumented with metrics, and then you can generate Prometheus and Grafana dashboards, very nice looking dashboards like this one at the end here. It's relatively simple, but very powerful mechanism for monitoring your app. And then the last few, I believe there's one on tracing for doing tracing both internal calls as well as external calls out to other services using Jaeger and open tracing. And then the last one is about security and using JWT or JOT to secure your Quarkus endpoints and using OpenID Connect and Keycloak to be able to offload the authorization mechanism out to Keycloak without having to modify your code. So it's very powerful mechanisms for securing your applications. So that's it. If you have additional time, you can run through those. If not, then all you really need to complete is the basic lab. If you've completed that, then congratulations. If you have any questions, you can go back in this video, obviously, or I'm also available during the lab time at J4K to answer them if you have any additional questions. So I will wrap up and hope you enjoy the rest of your conference.